The first thing we know about the human mind is that it seeks certainty. This need has been demonstrated repeatedly in simple experiments of choice based on what is called the Ellsberg paradox, where people are offered a chance to win $100 if they pick the right color of marble, say white, from one of two urns, each of which is completely opaque and has the same number of marbles in it. Participants know how many black and white marbles there are in one urn, but not in the other. Which one do they take a chance on? The one for which they know the proportion. If they draw out the correct color, they're asked to play again and choose the opposite color. Where do they go? Back to the urn they think they know something about, even though logically they'd have a better chance to draw out the opposite color in the unknown urn because no marbles have been removed. We overwhelmingly prefer taking risks where we know our chances, rather than in those situations in which the odds are completely ambiguous. Why? Because our rider's estimation of success is not driven by rational calculation, but by our elephant's fears. When faced with ambiguous circumstances, and it can't see what's going to happen next, the amygdala sends a jolt of negative emotional energy to warn the rider of danger. It's the same surge of fear we get when the lights suddenly go out. The second drive fulfilled at the non-conscious level is our drive to connect with other people. In a recently published book, Social, Matthew Lieberman opens his first chapter with a quote by philosopher Jeremy Bentham. "Pain and pleasure govern us in all we do, in all we say, in all we think." As he notes, human beings do avoid pain and seek pleasure. But the last 3 decades of neuroscience have demonstrated that this traditional view of human motivation is profoundly inadequate. More than avoiding threat and finding reward, we really need to connect. His own and others' research show how a group of neural pathways in the emotional brain light up every time we stop consciously problem solving. He calls it our social cognition circuit. It lights up when we're shown pictures of or asked to think about other people. Even in the midst of a math problem-solving exercise, when given only a 2-second break between problems, this circuit instantly comes alive. Why? Well, it's functional. Given the importance of our rider's ability to read others as we speak to them, the elephant must be always categorizing and retrieving information about the constantly changing circumstances and people it deals with. But more importantly, it's wired into us. Social connection is an evolutionary survival adaptation. We inherit our need to do this. As comparatively small creatures leaving the protection of the trees for Africa's open savannas, where the food was, we needed to connect with other people and organize ourselves to survive against predators, who were bigger than us. So we could hunt game that was, well, bigger than us. Whoever could figure out the minds of others to make and sustain social connections of cooperation got to live and passed on their genes, including those that fire up our social cognition reflex. To show the power of the need for connection, Lieberman and his colleagues demonstrated what happens when that connection is broken with a very simple experiment. Participants were asked to lie down in MRI scanners and play a video game of ball toss with 2 other people, represented by simple cartoon-like line drawings. They were told that the study was about how brain activity changes as people coordinate their activities with others. It was really about what happened in their brains when the others stopped throwing the ball to them. When they were debriefed after the experiment, many people spontaneously declared their anger and sadness at being snubbed. And whether or not people spoke about being snubbed, a particular circuit lit up in everyone's brain circuits when the game stopped throwing the ball to them. The same one that is energized when we feel physical pain. Loss actually hurts. So we need social connection, but not just any kind of connection. We need positive verbal connections, and we need to be treated fairly. First, what happens when someone compliments us? When it's personal and it comes from someone we know, it has the same rewarding effect as eating a scoop of ice cream. Again, common sense wouldn't predict this since compliments are intangible, and ice cream literally floods our mind with bodily pleasure, and common sense would be wrong. Even more interesting were experiments where compliments were being paid that were quite general and came from strangers. The reward circuit still responded strongly. And when we make a positive connection and the other person treats us fairly, we are doubly rewarded. Inside the scanner, the elephant's reward circuits light up when people were given a simple money-sharing task. A stranger is asked to share $10 with you. That player, called the proposer, makes a recommendation about how much each of you should get, and you, the responder, then decides whether to accept the offer. If you accept, then both of you get to keep the amount suggested by the proposer. But if as a responder you reject the offer, both of you get nothing. If the proposers suggested that they get $9 and the responders get $1, responders were universally insulted by and, of course, rejected the offer. They preferred to get nothing rather than let this insult go unpunished. This seemed to fly in the face of rational self-interest. After all, $1 is 100% more than they had at the beginning of the experiment, but it's what people did again and again. And the size of the offer didn't matter, only its proportion to the whole amount. A fair share was rewarding, and the reward circuit in the brain that floods the mind with a sense of pleasure is the same one that lights up when we eat sweet foods that we crave. An even more dramatic demonstration of fairness happened when the neural responses of individuals were observed as their own potential winnings were given to another participant. Wouldn't this be painful rather than pleasurable? I mean, who wants to lose their money? As it happened, the individuals who won a $50 lottery at the beginning of the study and then saw the other participant not win any money showed robust activity in the brain's reward system when the lottery loser went on to win money on subsequent trials, even though the other was winning at the participant's own expense. As subsequent wins brought the lottery loser earnings more into line with the winner's own earnings, their reward circuits lit up more intensely. Seeing a fair distribution of the winnings was more rewarding to participants than gaining more for themselves. In other words, fairness trumps selfishness, and just to remind you, it also tastes like chocolate. Finally, there's lots of data showing that when people have an opportunity to choose the work they do in experiments, they are more likely to enjoy it. And these are really mundane tasks. They're more likely to master it and even move on to finishing even more boring tasks, which they had a choice to avoid, simply because the experimenter asked them to do it. And we now have experimental data to indicate why people work harder to become more competent at jobs they choose to do, as opposed to jobs someone else asks them or tells them to do. Tasks in this experiment require complicated hand-eye coordination and were set to force everyone to make errors in the beginning. This permitted experimenters to record a brain signal representing the elephant's negative emotional reaction to making mistakes. Everyone's mind generates this signal, but in those who chose the task they wanted to try, the signal not only occurred with higher strength, but actually more often in the beginning. It seemed to be the force behind their rider correcting itself more quickly and more often. The folks who got to choose their work actively corrected themselves, achieved higher level of competence in the task, making far fewer errors, and felt better at the end. And those who were told which tasks they had to do, the error recognition signal was not as strong, occurred less often, and didn't seem to motivate them to improve. This appears to be the neural version of being disengaged. In fact, in the next segment, we'll discuss how these fundamental neural needs fit with our data about engagement and explain why engagement happens in a relatively small number of work units.